So I've been following quantum computing for a few years now, and it's kind of taken a few interesting turns in that we've talked about um, quantum supremacy, and now it seems like it's evolved into more like what can quantum computing today do. Um, I guess for starters, explain what Classiq does, and kind of give me the state of where quantum computing sits today.
Sure. So Classiq is a quantum computing software company. We develop the operating system and compiler for any quantum computer. And to connect it to the second question, so quantum computing isn't new. It was envisioned since the 80s, and the big question wasn't why develop quantum computers. It was when or even if. And if we want to summarize the revolution in quantum computing in the last few years, is the shift of the question, right? The if turned into when, and the when into relatively soon. And in order to realize this new era in computing, we need hardware and we need software. While many good companies are focused on developing the hardware, it's too early to bet on the winner, but we see amazing progress by many of them. We established this company 4 years ago as there isn't any quantum software stack. No one can really program quantum computers. And it was quite clear that it will be essential into the development of this new field. So this is what we do. We are a product company. The product is well adopted among large enterprises, academic institutions, and this is what we focus on.
And you work across the various quantum systems like Quantinium, IBM, et cetera. I guess how does that work out across the hardware platforms?
Yeah, great question. So the answer is yes. The compiler and the OS are complete hardware agnostic, both in the, I would say, superficial way of we are integrated with all of the available quantum computers, many dozens, but also from the deep way. The technology that we bring into this evolving software stack is the design automation, right? With Classiq, you don't need to specify the quantum program at the gate level. You specify a high-level functional model that is focused on what you want to achieve, on the application, on the algorithm, and then our cross-compiler is taking the high-level functional model and the hardware constraints. Constraints could be anything, the qubit count, the noise model, the connectivity, and so on, and it synthesizes a gate-level circuit that is optimized for a specific machine. So from one high-level functional model, you can get many different programs, circuits that are adapted and optimized for very different machines.
So how does your software either rely on error corrections, or I guess how does that impact the software stack? Because I know everybody's sort of chasing this error correction thing across platforms. I mean, I saw something, just recently from Quantinium, and there's a lot of papers flying around about error correction. And how important is that into, not only just adopting quantum systems, but also, how does that impact the software layer?
Yeah, great question. So eventually the software layer enables quantum software engineers in any industry, of course, any use case, to describe what they want to achieve with the quantum computer, to describe the algorithm, and the software stack is automating the rest of the process. Now, in order to realize some of the killer applications and more sophisticated algorithms, quantum algorithms, yes, you need a fault-tolerant machine and you need error correction, and therefore, these type of developments among hardware providers are very exciting. And from the software perspective, so it has two main effects. First, these fault-tolerant algorithms, the more complex algorithms, the HHL and QPE and Ensure and Grover are becoming more relevant for end users, and these are much more complex algorithms with millions and tens of millions of gates. So definitely you need design automation tools in order to develop them. You cannot do that at the gate level. So this is one key aspect. And the second key aspect, which is also interesting, is embedding the error correction schemes in advance of the compilation. So in the first place, you can get a quantum circuit with the error correction code on top of it as part of the compilation flow.
Okay. In terms of kind of quantum interplaying with supercomputing, and I have heard the term hybrid quantum computing a lot more. How do you see that playing out in terms of supercomputing and quantum and how that all plays together?
Yeah. So first, most quantum algorithms are hybrid. It means that there is the quantum acceleration done on a quantum computer, but parts of the algorithm are done on a classical computer. And this is definitely a hybrid workflow. So we will need classical computers as part of the quantum workflow by all means. On top of that, we see many of the HPC providers trying to embed quantum computers within the HPC stack, both from the hardware perspective. We see more and more HPC centers buying quantum computers and trying to integrate them within the HPC stack. And also from the software perspective, and this is something that we are very much involved in, we see development environment that are dedicated for supercomputing, like the HP Cray development environment. That so we work closely with HP on integrating Classiq as backend to HP Cray programming environment. So we allow by that the Cray developers to access quantum computers as well. A similar story with NVIDIA CUDA Quantum. So definitely it's going to be integrated, probably in the long term, but definitely in the near term. And this tight software integration is very important.
Okay. And I guess that brings me, Classiq recently announced a partnership with NVIDIA. I assume that's part of the hybrid supercomputing sort of play. I guess what's NVIDIA's role in the quantum computing space?
Yeah, so NVIDIA is becoming a more and more prominent player in the quantum space. It started 2.5 years ago with mainly with simulations, simulating quantum programs with GPUs that are very much suitable for these kind of simulations. And simulations are essential for the development of quantum applications, quantum algorithm. And that was a very natural partnership because Classiq enables users to compile the most advanced quantum circuits, and we are integrated with these GPUs, and we enable users to simulate them. So that was a very, I would say, a natural fit. Also the basis to a previous work published with Rolls-Royce and NVIDIA as well. That was a year ago, the simulation of the largest quantum circuit to date with 10 million gates. And more recently, like a year and a half ago, NVIDIA launched a CUDA Quantum, which is the quantum version of CUDA to some extent. And this is a very advanced quantum software framework that we work with NVIDIA to integrate Classiq with, and that is the basis to other activities as well. So it's quite, I would say, a natural partnership at the software layer of the quantum stack.
All right. Thanks for joining us.
Thank you so much, Laurie. Thank you.
Come on. Hi, I'm Larry Dignan with Constellation Insights, and we're here at ARX to talk about some of the emerging trends we were yapping about. Here with Holger, Liz, Veggie Doug, Plant-Based